Hi. In this video, we'll go over the in-text questions in the chapter of work and energy. And as before, I have already solved all of these, but we will go over them in detail as part of this video. So let's start with the first question. A force of 7 newtons acts on an object. The displacement is say 8 meters in the direction of the force. Let's take it that the force acts on that object through the displacement. What is the work done in this case? So we see that this object moves, there is a displacement of 8 meters after application of 7 newtons. So we know that the force is equal to force times the displacement of that object in the direction of the force. So this is important. What is applied in because when you apply the force, this moves in the direction of the force, and you might have seen this in our snooker pool table example as well, wherein when you hit the ball, you always place the cue stick in the direction of the pocket, right? So when you apply the force on that particular ball, the ball also moves in the same direction, and that is the distance that we always consider. So the displacement we always consider the displacement in the direction of the force. So it is force times displacement. So force is 7 newtons and displacement is 8 meters, so it is 56 joules. When do we say that work is done? So theoretical definition, we say that work is done when a force acts on an object or a body or an agent to create a displacement. So we see when an agent experiences the force and gets displayed to a certain and gets displayed certain meters, we see that work is done, right? So that is the theoretical definition of work. Write an expression for the work done when a force is acting on an object in the direction of its displacement. Yeah, we saw that work is equal to force times the displacement. If F is the force and S is the displacement, then F times S is what is the work, is what is the expression for work. Define 1 joule of work. So we saw that your joule is the SI unit for work, and which means that if you really expand this, I think it comes down to kg meter squared per second squared, and we can say that 1 joule of work is the energy required to exert 1 Newton force on a body to result in the displacement of 1 meters in the direction of the force. So work is force times displacement, and the unit for force is SI unit is 1 Newton. So work is nothing but the energy required to exert 1 Newton force on an object so that it moves 1 meter. Right? It takes a displacement of 1 meter in the direction of that force. That is what we term as 1 joule of work. That's when we say that 1 joule of work is accomplished when 1 Newton force is exerted on an object, which results in 1 meter displacement. We say that 1 joule of work is done. Right. A pair of bullocks exerts a force of 140 Newton on a plow. The field being plowed is 15 meters long. How much work is done in plowing the length of the field? Again, work is the expression for work is force times the displacement, and the force exerted is 140 newtons. The field being plowed is 15 meters long. So it's not said that the direction is different. The direction the displacement is different from the direction of the force. So we'll assume that it is in the 15 meters is in the direction of the force applied. So it is going to be 140 times 15, which is 2,100 joules. What is the kinetic energy of an object? So we saw that there are two parts to the mechanical energy of an object, which is one is your potential energy and the other one is the kinetic energy. And potential energy is the capacity of an object to do work, right, when it is at rest. While kinetic energy is the energy acquired by the object by virtue of its motion. Right? So kinetic energy is the energy acquired by the object by virtue of its motion. Like the cue stick, because it moved, it acquired certain kinetic energy. And what is the expression for the kinetic energy of an object? we derive that kinetic energy of an object from the formula for from the expression for work by substituting the third equation of motion for the displacement, and we derive that the kinetic energy of the object would be half times mass times the final velocity square. So it is half mv square is the expression for the kinetic energy of an object. The kinetic energy of an object of mass m moving with a velocity of 5 meters per second is 25 joules. What will be its kinetic energy when its velocity is doubled? What will be its kinetic energy when its velocity is increased 3 times? Okay. So let's say that the original kinetic energy of the object, which is K is kinetic energy is half mv square, and we know that the original, when it was traveling at 5 meters per second, we know that it is 25 joules, right? When velocity is equal to 5. Now, what it means is what will be its kinetic energy when the velocity is doubled? If you consider the velocity to be v, when you double that velocity, it becomes 2v, right? So Ke prime is the new velocity, the new kinetic energy that we will derive, which is half m. M doesn't change. The mass of the object doesn't change. Just the velocity has changed from v to 2v, right? So if you replace v with 2v, you will find that the new kinetic energy will be 4 times the original kinetic energy, right? Which will be like 100 joules. Similarly, applying the same logic here, when the velocity is increased 3 times, you will got to replace v by 3v in the original equation, and you will find that the new kinetic energy, which is Ke double prime, is going to be 9 times the original kinetic energy, so which is going to be 225 joules. What is power? We understood that power is the rate of doing work, right? And expression for power is energy or work divided by time, right? That is what is considered power. And we understood that the unit for power is in the honor of James Watt, and we call it 1 watt, right? We define power in watts. So 1 watt is equal to 1 joules per second. In fact, in English terms, you can say that power of an agent is said to be 1 watt when it does 1 joule of work in 1 second, or when an agent takes 1 second to complete 1 joule of work. We say that that agent has a power of 1 watt. That defines the unit for power. A lamp consumes 1000 joules of electrical energy in 10 seconds. What is its power? So we know that power is equal to joules by time. So it consumes 1000 joules in 10 seconds, which is 1000 joules by 10 seconds. So the power, its power is power of consumption is 100 watts. What is average power? So average power is nothing but the total work done by an agent by the total time. The work done can vary. The background for this question possibly is when an agent does different amount of work at different time at different point in time. The overall average power is nothing but the total work done by that agent by the total time. Let's say it completes 1000 joules of work in first 10 seconds, and it completes 500 joules of work in the next 10 seconds. So in that case, your average power has to be 1000 plus 500 by 20 seconds, right? So your average power is nothing but your total work done by the total time. I think we have come to the end of the in-text questions. In another video, we will take a look at the exercise questions for power and energy.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share and subscribe this with your friends. Thank you.